with 50 here, which was this, this, and this. Hence, this is equal to what there? 5 root 2. This is now equal to 5 root 2 plus, look out for root 18. That was this. That was what there? 3 root 2. So 3 root 2. At this point now, add them up. They are similar sorts. So root 2 root 2, we can add them. 3, 5 plus 3 is what there? 8 root 2. That's the answer to that. About 3, what do you have there? Root 32 minus root what there? 50. I have value for this. I just have it for the 2. What's the basic form of root 32? That becomes what there? Root 16 times root 2 minus, we got this as what there? 5 root 2. Is now equal to what? 16. That gives you 8. But can we use 4 instead? Can we use 4 instead, so save time. What's root 16 there? 4 times root 2 gives you what there? 4 root 2 minus what here? 5 root 2. That's now equal to similar sum, root 2 root 2. Subtract this. 5 or 4 minus 5 is what there? Minus 1. Becomes minus 1 times root 2 gives you what there? Minus root 2. Alright, so that's your work there. Let me go to number 5, number 4, right? Alright, so you do number 4, let's proceed. And number 4, let's proceed. Next up, let's look at conjugate of the sum. Conjugate of a sum. Given a sum A, where A is equal to, let's say, root m plus root m. Given a sum A, where A is equal to root m plus root m. The conjugate of A is written as A bar, which is equal to the coupled. When it comes to writing the conjugate of a sum, what do? Change the sign to the opposite, that's all. What sign there? Plus. It becomes what there? Root m. Change that to the opposite, it becomes what there? Minus root m. That's all. So this is what we mean by the conjugate of a sum. Given another sum, z, is equal to root a minus root b. The conjugate of z becomes z bar, which is equal to what there? Root a. That becomes plus root b. Change the sign to the opposite, that's all. Alright. Question? Yeah, it means like conjugate, right? It shows conjugate. Let's see multiplication of sums. Let's see multiplication of sums. Now listen, I said two sums can only add or subtract if they are similar. Just so that please. When it comes to multiplication, they don't have to be similar to multiply, please. That means two dissimilar sums can multiply. That's what it means. Alright? For example, let's say this example, evaluate the following. Example, evaluate the following. Example, evaluate the following. example, evaluate the following. So we have this. Well, let's not forget. Let's not forget solution. Thanks a lot. Start with this. Okay. Number 1. Ask us to evaluate root 2 into what then? 5 plus root 3. Observe, this and this are not similar. Yes, root 2, yes, they are not similar, but they can multiply. So it's now equal to root 2 times 5, this is what there? 5 root 2 plus this and this one there, root 2 times 3, 6. That's all. Look at this. We said this becomes root 2 times 3. And we said root 2 times root 3 is equal to root 2 times 3. That's 6. We have it to 6. And here is 5. I want to go outside there. That's 5 and 2. Number 2. Let's say I'm giving root 2 plus root 5 into root 3 plus 6. I'm asked to multiply this. Now listen. Whenever you ask to multiply terms in brackets, what do? Use the first term in the first bracket, multiply everything in the second bracket. Use the second term in the first bracket, multiply everything in the second bracket. That's the rule. So it becomes equal to first bracket, second bracket. Use the first term in the first bracket, that's root 2. Multiply everything in the second bracket. That gives you root 3 plus 6. Next up, use the second term in the first bracket, that's plus root 5. So I'm having plus root 5. Multiply everything in second bracket. That becomes root 3 plus 6. So I have this. Alright. If I work on this, it's now equal to this time, this gives you root 2 times 3 is 6 plus this and this 6 root 2 plus this and this root 5 times 3 15 plus this and this 6 root 5. I have this. Alright, can we break down the explicit form? Can we break down the explicit form? Yes? What and what? What's root 6? That's root 3 times root 2. But that can also be broken down. So here's the explicit form. What's root 15? 5 times 3. So root 5. It's not a whole number. So here's my answer, right? Can anything add here? Nope. They cannot add. Why? They are not similar sorts. So I'll stop here. In complex maths, you can see this one down if you want to. But let's never that part. Number 3, I'm having root 11 plus root 7 all square. This man, or this being square, means what there? It's multiplying itself. A squared is what? What's A squared? A times A. When it's square, it's multiplying itself. This now becomes what there? Root 11 plus root 7 multiplying itself, root 11 plus root 7. So I have this. Apply the same concept. Use the first term here, multiply everything here. So my first term there is what? Root 11 multiplying everything here, root 11 plus root 7. Take the second term here, plus root 7. So plus root 7 multiply everything here gives you root 11 plus root 7. So I have this. Alright, expand this. This is now equal to this multiplied set gives you what there? 11 plus root 11 times 7, 77 plus root 7 times 11, 77 plus root 7 times root 7 gives you 7. This is now equal to 11 plus. These two are similar surds. So my coefficient here is 1, becomes 1 plus 1. That gives you what there? 2. So it becomes what there? 2 root 77 plus what there? 7. Of course, this and this can add up. So it's now equal to 11 plus 7, 18 plus what? 2 root 77. At this point now, if you want to factorize, you're free. Here is 18, here is 2. So divide both sides by 2. So having 2, divide 18 by 2 gives you what there? 9 plus, divided by 2, 2 cancels 2, so it gives you what there? Root 77, right? 2 times 9 is 18. 2 times 77, 277. And that's your answer. That's all. What are you doing? Go. Next of this, division of surds. When two surds are dividing, write down. When two surds are dividing, comma. When two surds are divided, comma, simply rationalize. Rationalize on the board. When two surds are divided, simply rationalize. Now listen please. When it comes to rationalization, you rationalize in two forms. There are two forms of rationalizing. Here's your form 1. Form 1 of rationalizing is this. If I'm rationalizing a term like root A all over root B, alright? Let me say this now please. The idea of rationalizing is this. In maths, it's improper to leave the denominator of a fraction as a surd. That's the concept. Alright? You can see this is actually root A dividing root B. Here's your numerator, here's your denominator. I'm saying this thing. In maths, it's improper to leave the denominator of a fraction as a surd. So whether you see it in maths or in physics, it follows the same concept. So in sort of this form, how do you rationalize? Now, here's what we do. For a sort of this form now, if I'm to rationalize this, I will simply multiply numerator and denominator by the denominator. So it becomes root A all over root B. Multiply both numerator and denominator by the denominator. Becomes root b over root b. That's the concept. It's now equal to root a times root b. This is what there? Root a all over root b times root b gives you what there? B. Discuss it further. This side rationalize. This is form 1. Form 2 is this. If I'm to rationalize, what if this one here is a complex term? What if I have a complex term? Let's say root a all over, let's say root a all over root b plus root c, something of this nature. How do you rationalize this? For complex term, you rationalize a complex fraction like this by multiplying the numerator and denominator, not just by denominator, but by what there? The conjugate of denominator. So now becomes root a all over root b plus root c. Multiply numerator by the conjugate of this. What's the conjugate of this? That becomes root b minus root c. We said to get the conjugate, change sign the word there, the opposite. All over, here becomes what there? Root b minus root c. So this is how you work out division of surds. Right? Two forms. In a single form, just one number, simply multiply numerator and denominator by denominator to have this. In a more complex form, multiply numerator and denominator by the conjugate of what? Denominator. That's the concept. Okay, let's take an example. Example is first, for solution. Alright, let's do this. Let's do this. Obviously, this one follows this first step. That's the simplest form. I will say, how do you solve this? Multiply numerator and denominator by denominator. So hence, it's now be equal to what there? Root 2 over what there? Root 11. Multiply numerator and denominator by denominator. So root 11 all over what there? Root 11. So it's now equal to root 2 times 11, 22, all over root 11, root 11, 11. That's your answer. Number 2, I'm giving root 3 plus 2, all over root 2 plus root 7. So how do you solve this? So we said for this case, for a more complex case, multiply numerator and denominator by the conjugate of denominator. So it's now equal to root 3 plus 2 all over this one here, root 2 plus root 7. Multiply this by the conjugate of denominator, that's root 2 minus root 7 all over root 2 minus root 7. That's the concept. Work this out. What do you get? This is now equal to, how do we multiply these two things? We said use the first step here. That's what's here. Root 3. Multiply everything here. That's root 2 minus root 7. Next up, take the second term plus 2. Multiply everything here. Root 2 minus root 7. All over, same case over here. Use the first term, root 2. Multiply everything here. Root 2 minus root 7. Second term here, plus root 7 plus root 7 into this here. Root 2 minus root 7. So I have this. Expand this one after the other. Root 3 times root 2 gives you what there? Root 6 minus this. So square root of 3 times 7, 21. Plus 2 times root 2 gives you what there? 2 root 2. This one will not multiply this. Why? They are not good sorts. Next one, plus times minus. Minus 2 times root 7. 2 root 7. I have this one here. All over. Work on denominator now. Root 2 times root 2 gives you what there? 2 minus root 2 times root 7. Root 14. 7 times root 2 plus root 14 plus times minus root 7 gives you what there? 7. So I have it. Okay, this is now equal to, this is, can you see out of here? This is 7 times 3, which is not okay. Can you see out of here? No. So what do you get now? Root 6 minus root 21 plus 2 root 2 minus 2 root 7. This all over. This is 2. Minus root 14 plus root 14 gives you what there? 0. It's up. So I'm left with what here? 2 minus 7. I don't gives you what there? Minus 5. Now mind you, it's improper to leave the denominator of a fraction as a sum. We said so. Also, it's also improper to leave the denominator of a fraction as what? A negative. So what does it mean? In a case where I have minus 7, what do you do here now? Take the minus above here. So now gives you what there? Equal to, in brackets, minus this. Take off the minus here. So I have this. Are we good? If you want to, you can say expand. It will give you minus root 6 plus 21 minus 2 root 2 plus 2 root 7. Is it correct? Right, so this is like your answer. Alright, so that's it. Let's take some Jamb question and solve as many as you can. This one says evaluate. This here says evaluate root 2 plus 2 all over root 2 minus 1. Here are your options. A is 3 root 2 plus 4. B is 3 root 2 minus 4. C is 3 minus 2 root 2. D is 4 plus 2 root 2. So, evaluate this. So how do you solve this man? It's simply a question. We want that rationalization. That's a question here. So this is how we got from now. The solution makes that root 2 plus 2 all over root 2 minus 1 is now equal to, how do you solve this? multiply both numerator and denominator by the conjugate of denominator. It becomes what here? Root 2 plus 2 all over root 2 minus because what there? Plus 1. Okay, sorry, minus 1. As this, remember, this one now, multiplying the conjugate now, root 2, change it to what? Plus 1 all over root 2 plus 1. Alright. So what do you now get here? This is now equal to, use the first term, root 2, multiply everything here, root 2 plus 1, second term plus 2, multiply everything here, root 2 plus 1, all over first term here, root 2, multiply everything here, root 2 plus 1, minus 1, minus, you see minus into, no need to write 1 here, minus into everything here, root 2 plus 1. So here's now equal to root 2 times root 2, that's 2, plus root 2 times 1, that's root 2, plus 2 times root 2, that's 2 root 2, plus 2 times 1 is 2. I have this. This all over, this now gives you root 2 times root 2, that's 2, root 2 times 1, that's root 2, minus times root 2, minus root 2, minus times 1, minus 1. Okay, it's now equal to, what do I get here? These two can add up, 2 and 2, I have 4, plus these two are similar sorts. Why? They are multiples of the same sort. My coefficient here is 1. 1 plus 2 gives you what here? 3 root 2 plus 3 root 2 all over. Here is 2. Of course, root 2 minus root 2 is off. 2 minus 1 is 1. My answer is now equal to 4 plus 3 root 2. That's 4 plus 3 root 2, or root 3 plus 4. That's this. That's the answer. That's the answer. I'm not saying it's hard, but let's. Okay, let's try this. Say, simplify. Let's try to simplify root 5 into root 147 minus root 12. This divided by root 15. This divided by root 15. See your options. A says 1 over 9. B says 9. C says 5. D says 1 over 5. 1 over 5. Let's get this one done. Alright, so how do I solve this? First of all, write this one in a form you can easily grasp. Solution. If I rewrite this is equal to, of course, it means root 5 is multiplying all of this, and all of this forms my numerator. So that gives you root 5 into root 147 minus root 12. This all over root 15. Now you tell me, what I should do here? Rationalization. So how about that? So yeah, there are many ways of solving this. You can choose to expand bracket or rationalize. Multiply this and this by what this term. But here's the easiest way. Also sometimes you have to solve more problems so that your eyes open the question. Why I can choose to expand this first or I will say rationalize. Multiply this and this by this term here. In this case, the easiest way will be, I'm seeing root 5 outside. What's root 15? Root 5 times root 3. So hence, I can express this as being root 5 multiplying root 147 minus root 12 all over, what's root 15? Root 5 times what there? Root 3, 15. In this case now, root 5 are outside. What happens? We can cancel out. So this and now cancel this. I'm now having this. So it's now equal to, what's 147? Obviously this is not even. So 2 cannot divide this. Can they divide this? What would be your answer? Divided by 3, what do you get? That gives you root what? 4, 12, 9. Yep. Times root 3. Please do your maths very well. This is giving this. 3 times 9, 27, 7 carry 2. 3 times 4, 12 plus 2, 14. That's this. Alright. Minus, what's root 12? Root 4 times what there? Root 3. All over, what do you get now? Root 3. Right. What's root 49? That's 7. 7 root 3 minus, what's root 4? That's 2 root 3 all over root 3. So it's now equal to, these two are similar sorts. So 7 minus 2, 5 root 3 all over there, root 3. What happens now? These cancel this. My answer here is what? 5. That's option C. Alright, so these are like option you see. Right? So either something of this nature or something of this nature. Alright, so that's it on Surds. Next class, look at another topic, maths.